So I want to talk for a few minutes today about some of the challenges that EdgeCast has faced over the years as we've grown with scaling and performance, and give a couple of specific examples of changes we made where we've made modest changes to our code and our technology that have had very large effects on our performance and scaling. So a little bit, for those of you who don't know who EdgeCast is, we're a global content delivery and application acceleration service provider. We operate a multi-terabit per second content delivery network. We're in about 30 different locations around the globe. We service several thousand customers, including some of the most popular and highly trafficked websites on the internet. So I'm in the product management business, and for us, performance is our product. So it's one of the key things that people choose us for. And if we're not constantly growing, changing, evolving, we're going to get eaten, right? So if we're not delivering good performance for our customers and helping them deliver good performance for their customers, they're going to go someplace else. So we must always keep ahead of the competition, keep abreast of the pace of change that's going on in the general internet. And so there's a lot of sources of that change for us, and this is something we all struggle with. Scaling is a big one, continually optimizing performance, adding new functionality, dealing with bugs and operational issues, new technology that applies. So there's lots of different places that change comes from for us. And there's a huge number of dimensions of scale and complexity that get into the system. So it's kind of one of these Escher-esque pictures of the staircase, infinite staircase here. But increasing number of servers and devices. We have tens of thousands of servers around the globe. Traffic and request volumes, customers, configurations. Basically. String theory says the universe has 26 different dimensions. All of us that are trying to build at scale for the internet feel like we're operating in that universe, certainly. And so what we want to try to do is turn that scale and that complexity into a force multiplier. So it's one of our greatest challenges. We're constantly having to reinvent and redevelop components of our architecture, but we want to try to leverage that scale as a way to get magnifying effects for very small changes. So for us, a millisecond of efficiency in code times tens of thousands of servers out there might be 160 plus million opportunities to do some useful work on behalf of a customer, right? If we can get an additional gigabyte of additional cache efficiency and cache retention in our network, times those tens of thousands of servers, and we run multiple cache instances and multiple disks, obviously, on servers, that's thousands of hours of HD video for us. Potentially many libraries of Congress worth of content. If we can shave off 10 or 100 milliseconds of latency per request transaction that we're processing, on a web page that's got 20, 50 requests, we're making measurable improvements to the perceived user experience for our customers. And all of that translates into dollars, whether it's dollars saved for us, making our network more efficient, allowing us to operate more efficiently for customers, or it's our customers that are generating revenue because their sites are performant, because they're a leader in their segment. That's where small changes can have very big effects. Okay, so there's an adage, one of my hobbies in the little spare time I have is woodworking and carpentry, and the old adage of measure twice and cut once. You always want to, be accurate with what you're doing. Well, we take that to an extreme. At EdgeCast, we measure ourselves over 116 billion times every month. And that spans the entire stack. That's all the way from, hardware, operating system metrics, application level metrics. We've got anti-DDoS measures in place, and we're constantly measuring traffic patterns and establishing norms and looking for anomalies in that, and we can take very proactive, second-level response times to DDoS attacks. As you can imagine, we're a fairly large target for that because we serve a lot of different customers. We look at server configuration correctness. So when we bring up servers and change roles and deploy new infrastructure, the servers check themselves for are they configured in an appropriate status and are they correct before they bind themselves into a production capacity. Application server health checks. So this is a big one. So we have metrics that define whether or not a server's healthy to us. And so we're constantly looking at those and deciding if a server's not healthy, taking it out of rotation, et cetera. Customer configurations. So when we push out configurations on behalf of customers, they're going in and either self-servicing through the portal, maybe making changes through APIs, et cetera. When we push those changes, we're actually checking that those changes are correct, that they're not going to break the customer's application. And recently we've actually started taking tests that our customers can submit, that they can tell us what good looks like to their application, and we can factor that into our own Edge Verify tests. Obviously, external third-party testing and performance testing using all the different service providers out there, making sure that we collect a lot of data, and all this goes into ensuring that the network is up and healthy and that we can address problems proactively. And it also informs us about the kinds of changes we can make, and so that's when we're going to get into some more specific examples. So I've only got time for about 3. This is one that we made fairly early in our evolution. This has to do with, we noticed in our lab testing that as we added more configuration complexity, more customers, more virtual hosts in this multi-tenancy environment, that the throughput of our application actually degraded with that additional configuration complexity. So that's a big problem, right? We're going to service thousands of customers, and each of those customers have many configurations. We need to be able to support that and not have throughput of our infrastructure degrade, or it's kind of fundamental flaw in the business. So we looked at this data and we recognized that here's a couple of different changes we could make. This has to do with basically every time we get a request, we have to look up which account on our infrastructure is that request associated with, consult the appropriate configurations, execute the appropriate kind of edge-side business logic or configurations that the customers applied, and make sure their responses are served appropriately. And so what we noticed is when we had hundreds of configurations, and this is several years ago, the performance was very good. When we went to tens of thousands or hundreds of thousands of configurations, the performance degraded substantially. So we found 2 specific modifications. We modified that configuration structure. We separated out a few of those key components that are required for every transaction lookup, and we optimized the code. And you can see in the green line is showing you where the kind of lower throughput was before we made these changes, and you see 2 clear step functions as we applied these 2 different changes to the code. And so we ended up getting it to a place where it didn't really matter how many configuration elements there were in our system. That the performance, whether there were hundreds of customer configurations or hundreds of thousands of customer configurations, the performance was scaled linearly with that. So that was a big one. That would have been a critical problem for us as we grew. This is a more recent one. This is one we've actually just completed. So we offer an on-demand and validation system, so customers can purge content from the network on demand. Kind of gone are the days of where people can just apply a TTL and expect content to expire out of a cache with user-generated content, et cetera. We see a great increase in the volume of people exercising an on-demand and validation method. And so what we noticed is, as we grew and as we scaled and as we added customers, that the performance of those on-demand and validations got worse, right? There's a lot more load, a lot more volume. We're processing somewhere around the 1.5 million invalidations a day. And so we needed to make a retrofit to that system. And so a couple of things that we did. We re-optimized the way that we're organizing objects in cache to make disk operations much more efficient, so that when we actually issue the purge against the disk, it executes very quickly. We also deferred that. We applied something called an edge filter, which allows us to propagate the invalidation requests, essentially detect incoming requests against a piece of content that's been invalidated while those disk operations are still happening in the background. So we can make it very quick, very responsive, very efficient. And that turned the purge process from this complete push right to disk, which contributed to backlogs in the propagation infrastructure, to now we can actually pull those purges through the infrastructure. So it works really well. We operate kind of a hierarchical model, so some customers have parent caches, and what we call origin shielding to further protect their origin environment. And this allowed that system to function much more efficiently and effectively and scale better. It also allowed us to save a lot of infrastructure. Okay. Low on time. So last example is we noticed in wireless networks in particular, we saw this kind of 2-second banding problem where a particular wireless network, we were seeing microsecond level delays in the arrival of multi-packet request transactions. So whatever was happening, you'd get larger than a 1,500 character request transaction, and the 2 packets would arrive out of order. And that was actually tripping a bug in our kernel. We were able to detect that, fix that bug, and you can see what that did is it knocked essentially a repeatable 2-second delay down back to a kind of a normal 100 millisecond response time. So again, I guess key takeaways for us: own and control the code as much as possible, measure the entire stack from hardware to application, find metrics that matter or create them. In some cases, we've created our own kind of hybrid metrics, that concept of a health check. There's no single metric that we look at that determines the health of our application, but we construct these health check metrics that allow us to smooth data over time and look at what is the trend of our application as we make changes to the application environment. And measure as much as you can, as often as you can. The talk was just presented about big data being your friend. We definitely like the concept of putting more and more data into a shared repository. One of the takeaways for the community is, your service provider and you as a customer, we have mutually shared interests in performance and in performance data. So the more and more that we share data and work together to collaborate, the more and more we can tease out potential optimizations like this, both for your application as well as for infrastructure like ours. So with that, thank you very much, and enjoy the rest of the show.